Hi everyone, this is Melody Rondeau and I'm going to walk us through our lesson on displaying and describing quantitative data with graphs part 1. It's a very long lesson, so I did split it into 2 parts. And so here we go with our learning intention. I'm learning how to display quantitative data and describe the pattern of a distribution. Our success criteria: I can make and interpret dot plots and stem plots, and I can describe a distribution and identify outliers. So here we go. All right, so here are data on the number of goals scored in 20 games played by the 2016 U.S. women's soccer team. Create a dot plot of the data. So dot plot you probably already have done before, but we're going to go through it quickly. So a dot plot is based on a number line. So you're going to draw yourself a number line. And you want to make sure that you include all the numbers that you see in your data. So if I look at my data, the lowest number I see is a 1. So I'm going to go 1, and then if I count up, I look for the highest number I have is a 10. So I think I can count by very much by ones, and let's see, 1, 2, 3, 4, very exciting, 5, 6, 7, 8, 9, and 10. And you want them to be roughly equally spaced. And then I'm going to throw arrows on the ends because the line goes on. And then, of course, like we talked about in the past, we're going to label this. So these numbers represent goals scored in soccer games. So I'm going to just go ahead and say goals. That's my number of goals. And then I'm going to, for every number that I come across, I'm going to put a dot. And I'm going to show us how to do that. So there's a couple ways you could do it. You could go number by number, so start with a 5, put it on the graph, and so forth. Or you could go through and count up how many 1s do I have, how many 2s do I have. Either way works. I'm going to just go through number by number. So I have a 5 and then a 5. So I'm going to put a 5, a dot above the 5, and then I'm going to put another dot above that. So that represents my 2 5s. Then I go over to the 1, put a dot at 1, a dot at 10. And you want your dots to be roughly, of course, the same size and even the same distance when I stack them here. I want them to be roughly equal. Let's see, 1 and 1, 1, 1. Oops, that one got a little crazy. 2, 3, 3. So I have 2, 3, 3, another 2 and a 1, 2 and a 1, and then 4 and 2, 1, 2, 1, 1, 2, 1, cool, 9, and 3. All right, so we have created our first dot plot, and that's pretty much it. And so each dot represents one of the data values, and you can kind of see this overall shape or distribution form. Let's go forward. Describing distribution. So look for the overall pattern and any clear departures from the pattern. So looking back at the one we just did, I have kind of a lot of data grouped on the left, and I have those couple of points on the right and some big space in the middle. Those would be things I might notice. Overall pattern, when we talk about looking for the overall pattern, we're going to get into this shape, center, and spread. And with this word spread, you're going to see this almost every time also listed as variability. Variability, so I got to figure out how to spell that, which is like a variable. It's something that changes. And so what we're actually talking about is how much a variable changes. So spread is like how spread out it is, how many different options there are for answers, and we'll get more into that in a minute. But shape, center, and spread. Anytime we are describing distributions, we are going to talk about shape, center, spread. Anytime we're describing quantitative variables, we talk about shape, center, spread. All right, and departures from the pattern, what we mean by that is outliers. So this is anything that's a lot bigger or a lot smaller than the rest of our data. Something that stands out as different. All right, so to get us going on our topic of shape, We have a bunch of these pictures here. So we have skewed to the left. So skewed to the left is basically means the trail, or the, like, I call it the tail of the data is on the left side. So if I kind of trace over the top of this to give you, whoops, let me try that again, a picture like this. It's kind of the pattern of the data. We have a tail on the left-hand side. So there you go, the dot has a tail on the left. And then if we look at the symmetric, this is basically means roughly the same on both sides. For symmetric, most of the data is near the center, roughly the same on both sides. And if I were to try to trace the top of this one, you kind of get, this one kind of looks like a bell curve. And then the last one, skewed to the right. When we're talking about skewed data, we have a lot of data on one side and it trails off to a particular side. We're looking for, where does the data trail off, or where is the tail? So again, here, if I look at this, there's the tail of my data. So this one is skewed right. The dot plot has a tail on the right. So we definitely want to be careful with skewed left and skewed right. We want to make sure we're describing left and right based on where the tail of the data is. All right, then the one at the bottom here, this one is going to be our uniform idea, and that's because even though there are a few highs and lows, they seem to be relatively, like, it goes up and down, but for the most part, it's basically like all the things are about that high. Now we do have a little bit of low right there, but they're so similar. Looking across, there's not like an obvious peak. I mean, there are some high points, but because this, like, it goes down a little bit and it goes up a little bit and it goes, like, the overall pattern is very flat. We call that uniform. All right, forward. Some other words we use to describe shape: unimodal, bimodal, and multimodal. When you guys did your assignment on mean, median, and mode, it did ask you to find mode. That's actually our least common thing we do in stats, but this is the one place where we're going to see mode pop up. Unimodal means we have a single peak, so something like that. Dot plot underneath. As an example, there's one that stands out as the high point, or the mode. This number 2 right here would be our most often, our data value that appears most often in this data set would be the 2. So that's unimodal. Bimodal means 2 peaks. And bimodal doesn't have to be exact. Like this one, you can see the peaks are slightly different heights, but they do stand out as 2 peaks amidst the data. So that would be bimodal. And then multimodal is when we have a few different places. So this one, we kind of have 3 peaks. Here's 1, here's 2, and here's 3. So we kind of have 3 peaks, distinct sets of data, or distinct areas of data on our graph. So there we go with that. Moving right along. So let's see if we can put that to use in this one. Describe the distribution from example 1. So this is basically the dot plot from example 1, but just a pretty version of it. Are there any outliers? So we'll start with describing the distribution. We're going to start with shape. So that first question is, what is the shape of this distribution? Is it skewed left, skewed right, or symmetric? Since the data trails off to the right, this would be skewed right. Then we would talk about the center, which typically means we're reporting mean or median. On this one, because we haven't done a whole lot of that, it might be weird to look at this graph and try to figure it out. But we do know from example 1 there were, was it 20 goals scored? So the middle is going to be somewhere around the 10th goal. So if I look at this, I could actually count my dots. 1, 2, 3. So I'm starting right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm in the 2 column, so the center would be 2, or I would say the median is 2. So when you're reporting center, you don't necessarily have to say the exact number. If you haven't done any statistics or calculations, you can just estimate, but In this case, we could easily count and find the median is 2, and then shape center, and then spread. What we're looking for with spread is how spread out our data is. So we're going to actually cheat. We are going to be talking about range very soon, but range is a very quick way to explain spread. And so in this case, the range would be the highest, which is the number 10, minus the lowest data value, which is the number 1. When I subtract those, I get 9. So my spread has a range of 9. And then finally, are there any outliers? So we're always going to do shape center spread. And then are there any outliers? This one, are there any points that appear to be a lot higher or lower? These both out here, although they are together, they are quite a bit bigger than the others. So I might say something like this for outliers. And actually, most of the time, this is how we will report outliers. We will say something like 9 and 10 appear or are possible outliers. I'm going to say appear, but we use language that suggests that we're not 100% sure. There is a way to be 100% sure. We'll learn it eventually, but for now we're just going to kind of say, hey, it looks like they might be. So 9 and 10 appear to be outliers. There we go. And that would be describing a distribution. Now notice I did this in not complete sentences. Most of the time when we do shape center spread, it depends on the context, but if it's a quick thing like this, I won't bother doing sentences. I'll say a literally list shape center spread outliers and then say what they are. If we're in the middle of a context of a problem more specifically and I'm asked to compare, then I would use complete sentences. All right. Stem plots. This one is probably new to you. They're called stem and leaf plots, stem plots for short. And they're a little bit different. They're like a modified version of dot plots. So a stem is all but the final digit of a number. And I'm going to show you definitely how to do this, so don't freak out if you're like, this doesn't make any sense. The leaf is the final digit. So the stem is all the digits but the last one. The last digit is called the leaf. You have to include a key on your plot. This is one, if you don't include a key, then you get marked off. It doesn't count. And then there's going to be something in a minute. We're going to talk about splitting stems. So for right now, just jot these notes down and we'll definitely practice it in a minute. We're going to do this when there are 4 stems or less, when we don't have a lot of variety in the first part of our numbers. We're going to write each stem twice, and we group the leaves into equal groups by 0 to 4 and 5 to 9. So let me clarify here, equal groups. 0 to 4, if I think about what numbers that includes, that's actually 5 numbers. We have the numbers 0, 1, 2, 3, and 4. That's 5 numbers. In the group 5 to 9, we have the numbers 5, 6, 7, 8, and 9. So when we think about digits, even though we want to say something maybe like 1 to 5 and 6 to 10, by the time I get to 10, that's a 2-digit number. So I have to be careful here just to make sure my my groups of leaves have an equal chance of being chosen. And you might not quite understand what I mean, but again, the group 0 to 4 has 5 digits in it, and the group 5 to 9 has 5 digits in it. Here we go. Let's give it a try. Below are the data for the resting pulse rates of 19 middle school students. Use the data to create a stem plot. 1, 2, 3, 4, 5, 6. I think that this might only have 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Whoops, it's 18. Sorry. 18. We're going to use the data to create a stem plot. All right. So if I look across at this, my last digit, so I'm always going to go last digit is going to be my ones place. That's going to be my leaves. So my stems are the other numbers, which is either like the number, if I look at this one, the stem would be the 7 and the leaf would be the 6. But if I look at the 3-digit number, like 104, my stem would be the 10 or the 10, and the leaf would be the 4. So in theory, my stems are supposed to all be the same number of digits. So this is how I fix that, because the 76 only has a 7 as a stem. I would do a 0, 7. But let's get to it. Let's see what my lowest is. Looks like a number in the 60s. So first of all, I'm going to draw myself a nice vertical line. And then I'm going to list, I'm going to do 0, 6. That's for my 60s. I'm just giving it 2 digits. Then I have 0, 7, 0, 8, 0, 9, and then 10. Remember, this stem represents I'm going to do that again, represents the first 2 digits of your number. And so the 0 you can basically just kind of ignore. I'm listing it so that they all look like they have 2, but really it's just like the 60, 70, 80, 90, and then the 1, 0 stands for 100. All right, so those are my stems. And then for the leaves, we're going to list out the final digits. And so I'm going to start with the 60s. And if I look across, I have 68, I have 69, 68, and 68. So I'm going to look at those 4, even though I crossed them out. In my final digits for those numbers, I have 2 8s, 3 8s, and a 9. So I'm going to list them in numerical order. I have an 8, I have an 8, and I have a 9. Then I'm going to go to the next one. So my 70s, if I look at the 70s, I'm going to try to do these in order. Let's see, I have 70, so I have literally a 0. Then I have 71, so then I would put a 1. And again, the numbers here, like with the dot plot, you want them to be roughly equally spaced. Next, it looks like I have 74, 76, 76, and 78. So I list the final digits in order. Then I go to the 80s. So let's see, in the 80s I have, it looks like 82, 86. So I'm going to go 2 and 6. And then it looks like 2 88s. So then 8 and 8. And then 90, I only have the 1. So I put a 0 for the 90. And then 104, ooh, I didn't realize I had 120 over there. Whoopsie. We'll add that in, no problem. 104, I'm going to put a 4. But I need to extend my thing here because I have also, I'm going to make sure I include all the stems, even though there's not a 110 number, a 1, 1 as my stem. I have to use that to get to the 1, 2 for my 120. So my 120 is 1, 2, and then 0. So there is my stem plot. Before I'm finished, though, I have to create a key. I have to explain what these numbers mean, and you can kind of pick anything along the way. I'm going to just pick the last one, which was 120. So I'm going to say, here's my key, and I'm going to say 1, 2, 0. So that little slash represents the line. So 1, 2, there we go, 0. This, still not very happy with that. This, I have to say what it represents. So the 1, 2, and then with the 0, this represents um, 120. Let's see, resting represents 120. It doesn't say it on this part, but it is beats per minute. Maybe it says it on yours. Beats per minute is what this is being measured in, and I apologize if it doesn't say it on your thing. That's what it's supposed to be. 120 beats per minute resting pulse. So this is a resting pulse. And so this part becomes crucial to understanding a stem and leaf plot. So there we go. Our stem and leaf plot is finished. Now, this is gonna, we'll talk more about this later, but this is basically very much like a dot plot turned on its side. And instead of dots, we have the leaves to represent them. So we see the data values there instead of dots. It's an interesting way. All right, let's look at example 4, because this one asks us to make a split stem. So below are the heights of male students in centimeters randomly selected from students in the United Kingdom. Make a split stem plot of the data. So this one, if we look at our numbers, we have 3-digit numbers. So our stem is going to be the first 2 digits and the leaf is the last one. So if I look at my first 2 digits across, I have 15, I have 16, I have 17, and I have 18. So I have 15, 16, 17, and 18. Only 4 stems. When you have 4 stems or less, this is when we're going to do a split stem, so we spread out our data a little bit more. So here's what I'm going to do. I'm going to do 15. I'll build my stem and leaf plot. 15, 16, 16, 17, 17, 18, and 18. All right, so on any given stem, so like the 15, in the first set, this is gonna, my leaves are gonna go 0 to 4, and the second set, my leaves are gonna go 5 to 9. So as I look across my data, I'm looking for the 150s, so I have 154, 57, 59, 51, I think I got them all. Double check. Looks good. Okay, so anything 1 through 4, so I have a 1 and a 4. I'm sorry, not 1 through 4, 0 through 4. I have 1 and 4. I'm going to list them in numerical order, 1 and 4. My other numbers, the 7 and the 9, for 157 and 159, they go in the second group. So it's just basically splitting it. So then on the 16s, I'm going to do the same thing, 160. I'm going to do 160 to 164. So let's see if I can find just those numbers. I have a 3, I have a 2, and that might be it. 3 and 2. So I'm going to do in order 2 and then 3. And again, we want our numbers to be roughly the same. Try that again, 2 and 3. Okay, and then the rest of my 60s, I'm looking for 5 to 9. I have 167, so I have 7, 9, 5, and 5. So put those in order is 5, 5, 7, 9. And then I go to the 170s, again looking for the lower numbers first, 0 to 4. I have 174, so I put a 4. Then the higher numbers, 5 to 9, I have 6, 7, 5. So I'm going to do 5, 6, 7. Then I go to the 80s and I do the lower numbers first. I have 180 and 183, so 0 and 3. And then finally 187 goes in the higher group. I need to make sure that I include a key. So here I would say, once again, this time my key is, I'm going to do 151. I'm just picking the first number, 151. And this represents, I just have to say what it represents. 151 represents heights, or sorry, not heights, it's a specific height, sorry, got distracted there, represents 151 centimeters. And actually the other one I gave more context and said the resting pulse rates, but really this would be enough information. 151 represents the 1-5 with the slashy, and the 1 represents 151 centimeters. I'm going to be a little extra and say the height of a male student. But really, you just need that first part, and you would be good. All right, so here's my key. And that completes our stem and leaf plot. So this is called splitting the stems, when we make each stem have 2 parts to it. It kind of spreads out our data a little bit more. So it's not too clumped together. Again, that's what we do when we only have like 4 stems or less. All right. Oh, apparently that is it, people. We finished. There you go. Check off, take a minute and check off your success criteria. And I will see you guys back later. Make sure you are working on your homework. And yeah, have a good day.